Okay, here, the class here, we're gonna be comparing the triangles of a rock climber's perspective and the perspective of a mountain. So here, the class we're gonna be finding the value of the mountain using what the rock climber used. Okay, so here the rock climber, what the rock climber did was the rock climber needed to measure the height of the mountain, so the rock climber can buy enough rope to climb the mountain, right? This should be safe. So next one here is how did the rock climber try to figure out the height of the mountain? Here, since the rock climber is gonna measure height, what did so you knowing that you're gonna be measuring it using similar triangles. Since you're gonna measure the height of the mountain, the rock climber is gonna use the height of the rock climber itself. Knowing that we're gonna be using the height, we automatically know that there's gonna be a right angle. Okay. Here, the next theory here is the rock climber is going to use the rock climber's eyes, the peak of the eyes, and what he's going to do is going to visualize the mirror, right? The rock climber is going to look at the mirror until it's at the right measurement of the peak of the mountain. So using this reflection from the peak of the eyes to the peak of the mountain, right, the rock climber determined that the two angles here are also going to be congruent based on the reflection of both of the highest points of each measurements. So now the rock climber proved that the two triangles are similar using the angle similar triangles theorem. Okay, using the angle similar triangle theorem, then rock climber can start implementing the other measurements. So here, from the distance from the mirror to the mountain is 34 feet. The distance from the mirror to the rock climber is 6 feet. The measurement of the height of the rock climber to the ice is about 5.5, and the height of the mountain we don't know. So here, what we're going to do now is we're going to be comparing the rock climber triangle and the triangle of the mountain. Everything we're going to be comparing is the height, right? The height of the rock climber and the height of the mountain. Height of the mountain rock climber is 5.5 feet, and here we don't know the height of the mountain just yet. Next one is we're gonna measure the distance from the mirror, right, of the rock climber to the mirror, and the distance from the mountain to the mirror. The distance from the rock climber to the mirror is about 6 feet, yeah, and then the distance from the mirror to the mountain is about 34 feet that the rock climber measured. Um, so here, what we're gonna do next is we're gonna be using ratios and proportions to determine the value of the mountain. So here, 5.5 feet, I'm gonna use the ratio that we just wrote here, equals to 6 feet over 34 feet. And here we're gonna use the values here. Here we're gonna use cross multiplication. 5.5 times 34 is about 187 equals to 6 times x is just 6x. And here, last step we're going to do is we're going to divide 6 on both sides. And x equals to 31.17 feet. Here, the next one I'm going to be covering is this is a map diagram of a lake, and what we're going to do is we're going to determine the height of the, or from this point, what the person want to do is want to measure the points from the width of the lake, this part, how far are they apart. What the person did was make sure to use a, from this point to this point, the person did is they used a, go it straight, and what it did was they made a perpendicular line on the map. And the person did was just drew a straight line here. Okay. And here is going to be drawing another perpendicular line down here. And here what the person is going to do now is, once again, the person drew a perpendicular line here and drew a perpendicular line here as well on the diagram. So now the measurement here, trying to find out the measurement of the lake, and here this measurement is about 120 feet measured on the map scale. And what the person is going to do is going to combine the 2 points that was used on the map and combine those 2 points. So here, when you combine the 2 points here, right, what happens is it makes vertical angles. Okay. Once again you got right angles because we used in the math diagram we used perpendicular lines, and also we used vertical angles in the end when you combine the 2 points of the two perpendicular angles or right angles. So here we can finally find the value of the lake, or the length of the lake. But first here we're gonna put the measurements here. This is gonna be 90 feet, and this is gonna be 135 feet. Okay, so here we're gonna be comparing the small triangle to the large triangle. Here we're not gonna be saying side 1, side 2 because we're not sure if this is smaller or bigger. Or based on the diagram, right? We can just draw from this is the base of the triangle, spoke base. Or you can just say side 1. That's how you want to label it. Side 1. We're gonna be comparing from the small triangle. We're gonna be comparing 90 feet, and 90 feet is corresponding to 135 feet. And here we're gonna compare side number 2, which is from the small triangle, equals to 120 feet, and here the value of x. Next one here is going to be we're going to use ratios of proportions. Using this ratios and proportions that we just found, it will be 90 feet over 135 feet is going to be equals to 120 feet over x. So here when you cross multiply, it will equal to 90x equals to 120 times 135 is about 116,200 feet. When you divide 90 on both sides of the equation, x will equal to 180 feet. That's pretty much the lesson. Hope it's helpful, class, and thank you.